Hello, and welcome to Kotlin More Than Just Android. My name is Justin Lee, and I'm a developer at Red Hat, and I work on the Corcus microservice, microprofile-based framework. And I'm also a huge Kotlin fan. I've been a fan of Kotlin for many, many years now, and I'm really, really excited to see how big it's growing and how it continues to evolve into some really amazing spaces. And Kotlin was really the very first language that enticed me away from writing Java. I'm a Java champion. I've been doing Java since 1996. And for me, Kotlin was the first language that felt really kind of good enough to migrate all my stuff to. And so I did that several years ago. I moved my first big project over to Kotlin in 2015. And I've been trying to do as much as I can with it ever since. But many of the Kotlin devs I talked to, I'm one of the co-leaders at the NYC Kotlin meetup, New York City Kotlin meetup. Many of them only do Android. They've never really written any backend applications, and so the thought of writing non-Android applications in Kotlin just hasn't occurred to a lot of them, because why would they? And that's a little frustrating for me, a little disappointing, because I personally love Kotlin, obviously, but I've never written a single Android app. And there's so much that Kotlin has to offer on the back end, but it never really gets considered for a lot of people. So what I want to do today is I want to showcase some of the more prominent kind of non-Android options for Kotlin on the back end. And we don't have a whole lot of time together, so I just want to kind of go through kind of a quick whirlwind tour of some of the bigger players to kind of give you an idea of what's out there, and we can talk some options there. But the beautiful thing about Kotlin is it was designed to interoperate with Java as seamlessly as possible. So virtually any Java library out there, whether it's a framework or a library or whatever it might be, you can use it in Kotlin with very little problem. So you can pretty much use any framework you want to write Kotlin on the back end, but these options give like specific Kotlin goodness to the mix and make it a little bit simpler to use on the back end. So we'll look at some of that stuff. So what I'm hoping to do today is to whet your appetite for Kotlin on the back end if you haven't considered it yet, because it is a great option. And what I really hope to do is to inspire you just to write Kotlin everywhere you can, because there's really no reason you shouldn't, no technical reason I should say. And it's a great choice for kind of whatever your computing needs might happen to be. And then once we're done with that, if there's anything that comes up in the slides that we're going to take or the content we're going to take a look at, we can answer hopefully any questions you might have in the Q&A, and then we can just kind of follow where the discussion takes us there. Okay, so for our last few minutes together, I wanted to go through like a series of options you have for writing stuff on the back end. Primarily, we're going to look at kind of web microservice frameworks, because that's typically at least the entry point on the back end when you want to start talking about this or that. So that's what we're going to look at today. And then we'll look at some desktop-y stuff, and then depending on how much time we have left, maybe take a brief peek at some other things. But time is short, so we're going to try and get through this as quickly as possible, and then anything we miss in this session we can perhaps discuss in the Q&A afterwards. So with that, let's start talking web frameworks. And I would be remiss if I didn't start with like the most Kotlin-y version of that answer. And that seems, the definitive answer there seems to be this library called Ktor, which started off as like an early DSL experiment for this or that, and has kind of evolved into a super feature-rich framework. Probably more features than I could process at this moment. But if you want something like purely Kotlin, written for Kotlin by Kotlin people, then Ktor is where you want to go, and you can find it at ktor.io. And it has a number of interesting, because it's written in Kotlin and for Kotlin and by Kotlin people, kind of all the rich Kotlin goodness comes out in how the language plays into the library. So for example, if you want to do, as the website says, the simplest Ktor application. So in this case, we're going to do fun main, which is
the equivalent of public static void main from the Java world, but in Kotlin you just need fun main. You can take an array of string as arguments if you want, or not. Most people, I think, don't probably use those arguments overly much. But regardless, this is the simplest way that you can start a Ktor application. So in this case, they're defining an embedded server. They're using Netty, running on port 8000. As you can see here, they're passing a lambda to this embedded server. And in here, what they're defining is the routing. So all of your route endpoints, if you're coming from the JAX-RS world, this would be, like your @path, and then you have like @get, put, @post, kind of whatever. Ktor defines a very handy DSL to do this. There's the starting point here. We're defining the routing for this embedded server, and we're passing in yet another lambda. We're going to define a get endpoint on the root, and all it does is it returns the response text of hello world. And there's some internal stuff here, where call comes from everything, which we're not going to get into now because it's a little involved to get too much into the weeds. But this is what a very basic Ktor application looks like. You can get a little bit more complicated in your routing if you so choose. Here, for example, there are multiple endpoints, a get on /customer with an ID as a URL parameters that can be used inside the function body there. There's a post on the /customer endpoint, and then a get again on order instead of ID. So you can define them like this, but you can also, if you want to, you can group them together. So we're going to define a route on /customer with a get endpoint and a post endpoint. You can put your various handling logic in those particular functions depending on what the incoming HTTP verb looks like. And you can nest them, of course, if you wanted to do so. And then you can use extension functions if you want. So you can define your functions elsewhere so that you don't have them all, if you had everything defined in one giant routing block, your simple application suddenly becomes very large just to do the starting point. So you can kind of map all those out into separate functions and separate classes if you like. Now, if you've done Java backend development, then you've probably used Spring Boot, and if you haven't, you know someone who has. So this is the obvious second step because it is the biggest player probably in the Java world, at least in the microservices universe. So Spring Boot added Kotlin support 2 or 3 years now, I guess, and they have some rather robust options for you. If you've used Spring Boot, this should all look very familiar to you. They have their Spring initializer. You can come in, define whichever options you want. You Gradle or Maven. You can use Kotlin. You can use Java. But we're here to learn Kotlin, so why wouldn't we? And just like every other Spring Boot application, just choose which modules you want, which extensions, and then generate. And it will generate a whole new package for you. And you load it up, run it, and suddenly you're running Kotlin on the web. Super handy, and if you're familiar with Spring Boot, it's definitely a great place to start. Next is Corcus, which is near and dear to my heart. I happen to work on the Corcus team, but this is not going to be a Corcus pitch as such. There are other venues for that, but I do want to mention Corcus because it also has Kotlin support. Part of my job is to enhance and round out the Kotlin support inside Corcus. So if you're not too keen on getting tied up into the Spring ecosystem, which some people are for various reasons, then Corcus is a great option. It uses Rest Easy and Hibernate. If you're familiar with CDI for microprofile, it all uses kind of standard Jakarta EE microprofile sorts of libraries, so it should all be very, very familiar to you. And even though most of it is not written in Kotlin, as is the case with Spring Boot as well, because Kotlin is designed to interop with Java, it's very natural to use Java libraries from Kotlin for the most part, but each, both Spring Boot and Corcus, do provide a number of Kotlin idiomatic ways to interact with the system, and those, of course, will increase and improve over time. So Corcus is a great choice, and we can talk about that some other time without getting too sales pitchy on it. Another one is Micron, which is also quite popular. A lot of people are, like to use that if they're not on Spring Boot or Corcus. I'll have to confess I'm a little less familiar with this because I just haven't had a chance to play with it much, but they have rather robust Kotlin support in as well, and as you can see here, they also have support for Ktor. So if you'd rather use Ktor as the underlying transport layer instead of, I believe it uses Netty by default, you can actually use Ktor and wire in that way. So if you're familiar with Micronaut and all of its injections and annotations and lifecycle support and everything, you can still use all that on top of Ktor, which has some interesting multi-threaded concurrency capabilities that you don't necessarily see as a developer, but you will definitely experience them as on the ops side, because it's quite nice. So those are, if I had to pick, the top 3 or 4 web frameworks, that's what I would look to for Kotlin. There are dozens of more kind of niche or boutique frameworks, and I don't say that to denigrate any of them. There's some amazing work going on in terms of like pushing the boundaries with Kotlin and DSLs and such, but they're just not as popular, so finding support or someone who also knows those libraries might be a little bit harder, but it might be worth it to try some of those smaller ones as well, because they might really scratch your particular itch. So moving away from the desktop, from the web to the desktop, because we have just a few more minutes left and I don't want to run over as much as I can. If you've ever talked about Java on the desktop, of course, it was swing for a long, long time, but the new hotness is JavaFX. I've seen some amazing JavaFX applications written, doing some pretty stellar work in aerospace work, for example, putting things in orbit around Jupiter, and that's not an exaggeration. It's pretty stellar. However, there is a library called TornadoFX, which it provides a number of Kotlin extension functions and DSLs and convenience methods for building your JavaFX applications in a much more idiomatic Kotlin way that helps reduce kind of the boilerplate needed to build out such an application. The documentation is fairly extensive. Let me see, you have to build your layout, for example, it might look like this, which is a nice little DSL, creating a virtual box button. You can define the action on it, and it pops out like this. These are all basic examples, of course, but it really leverages the power of Kotlin to reduce the amount of code you have to write in order to build your JavaFX applications. One I wanted to mention, even though I'm skirting dangerously close to Android, and I promised we wouldn't do this, is this thing from JetBrains called JetpackCompose. It originally, as I understand it, started off as a Android kind of application framework for building Android applications for Android devices, but it has since expanded to the desktop, which is now in alpha, according to the website. I thought it was beyond that, but the website still says alpha at least. But it provides fast reactive desktop UIs for Kotlin. So it's based on some stuff from Google and JetBrains, and as I understand it, they're working together to build this framework for building applications. And what makes this really stellar, and what might make it interesting to those of you who write desktop applications, is that you can use much of the same code base for the desktop version of the application and the mobile application version of it. So you can share a whole lot of the code in between each module. And then there's also a third component of this, which is not as far along, I believe, as the mobile device and the desktop is. There's also, I believe, work being done for web. So you can actually build the same application for desktop, for Android, and for the web. And even though obviously some of the UI components won't necessarily carry over, much of the logic and the wiring behind the scenes can be reused, and then you just kind of have to swap out perhaps certain UI elements to make something a little bit more natural for whichever platform you're building on. But then you can share all the rest of the code in between the projects in one code base. So that's JetpackCompose, and hopefully you can see the URL up in the URL window here. And then one last thing before we stop and move on to Q&A, because I think I'm running over now, is here's a list. This website's called Awesome Kotlin, and it has a number of links and resources off to kind of everything. So just the base awesome tab, has courses and books. You scroll down, you see all these libraries and frameworks. There's Ktor, of course. Here's HTTP 4K, which has 1,700 stars on GitHub, which is nothing to laugh at. There's a lot of work is being done with Kotlin in data science, which makes me happy. So if you're not a huge fan of Python, for example, you can actually use Kotlin with Jupyter notebooks, with Kotlin Jupyter. There's all work being done there. There are some specific testing frameworks you can use to make it a little bit more Kotlin friendly inside your tests. There's some database specific. This JetBrains Exposed is a kind of a nice type safe DSL over SQL queries in Kotlin, which is very interesting. Some kind of custom dependency injection, this and that, and the list just goes on and on. If you click under resources, you can get like what's the latest hotness, depending on kind of what you're looking for. In resources and courses. I also wanted to point out this last tab especially, so wherever you happen to be in the world, there are, and I know I'm scrolling quickly, but you're not intended to read all this, but I just want to show you all the user groups around. Hopefully there's one near you wherever you happen to live. But in the time of COVID, like most of them are online anyways, or a lot of them are online. They have the resources to do that. So please do find a meetup, user group somewhere nearby, and just kind of hang out and see what the vibe is and learn what you like. You don't have to actually write Kotlin code. You don't have to commit to it. To join a group, you can just kind of join one and see what's happening. So with that, I want to leave a couple of resources. Kotlinlane.org is the primary website. All the official documentation is there, tutorials, it's all there, all you could ever want. There's also play.kotlinlang.org where you can actually run code in your browser, so you can experiment with Kotlin code without having to install anything. If you like to use Slack, there is a Slack workspace for Kotlin that has over 30,000 people in various channels. It is a great resource. There's dozens of different topics you can follow and create your own one. If you're more of the IRC type like myself, there is Pound Kotlin on Freenode, where you will find me hanging out most days. And of course, Awesome Kotlin, which I just showed you with all those links. Yeah, so there's a ton of information there. I hope this was a little bit helpful to get your appetite kind of whetted for what Kotlin might mean for you on the back end. And of course, if you have any questions, we can discuss them in the Q&A. Again, my name is Justin Lee, and you can find me on Twitter at EvanChuli. That's also my GitHub handle. You can find me either place there. So if you have questions, please feel free to reach out and ask questions, and I can at least try and point you in the right direction and get you squared away. All right, thank you so much.
Hi, Justin. So happy to have you.
Hello there.
Very, very happy. Thank you for being here. I actually like your talks. As I told you, you're one of my favorite speakers. And this is a topic that you find you actually do like, and I like when the speakers talked about what they really, really like. And thank you very much for that. It was really interesting and with a lot of resources. So You were really fast at answering the question, so I don't have a lot, but I do have 3
I tried
or
to be.
4.
I think I missed some.
Yeah. For example, well, I do have one for you. Is the Kotlin 1.5 was just released May 5. What can you tell us about the new release? What is exciting for you?
Well, one of the things, honestly, that I've been looking forward to is they actually like rewrote the entire compiler, and that doesn't really necessarily affect developers as such. But I've been kind of eyeballing it because one of the things that I do on Corcus, which is one of the reasons I brought up in the talk, was I'm the guy adding support for Kotlin, these sorts of things inside Corcus, and we do a lot of bytecode manipulation. So I was a little worried that they would change how that bytecode gets generated and it would just completely mangle everything I worked on. But kind of so far so good. I'm in the process of actually now trying to port it over, and tests are failing weirdly, so who knows. But I haven't actually gone over the list of things to look at because I don't get to write Kotlin that much in my day job just yet. But I do try to do it in my side projects, and I have some open source stuff that I'm going to migrate to that.
Actually, about that, what about Morphe and Kotlin? Tell me.
Morphe and Kotlin. Okay, for those of you who don't know, and that's probably most of you, I used to work for MongoDB, and there's this layer called Morphe, and I like to describe it as Hibernate, but for Mongo. So you annotate all your Java objects, and Morphe shuttles it back and forth just like Hibernate would do. There is support in Morphe for Kotlin. I actually, in this upcoming release that hopefully will be out in the next week or two, there's a specific module for like supporting data classes inside Morphe, because those are slightly different from a reflection standpoint. But I'm adding more and more support. At some point, I'm going to port all of Morphe probably to Kotlin because I like writing in it. But I'm trying not to leave anyone behind. And of course, I have to make sure that Kotlin is really great. It's designed to interop with Java, but if you're not careful, you can expose the fact that it's a Kotlin library to your Java developers because of a certain way that Kotlin does some magic, especially around like generics, that can sometimes leak out if you're not careful. Scala is really, really bad about that. So one of the questions was, why Scala over Kotlin? Why Kotlin over Scala? Scala is a fine language, and I've tried to use it and I've tried to like it, but it's never been like a professional thing for me. But if you've ever tried to use a Scala library from Java, it's very obvious that the library was not written in Java, and it's really hard to use. Whereas Kotlin, that's not the case. You can write it in from Java. You'd see something like, what is that? But it's usually generally good about creating Java-friendly APIs. Even with one of the things that Kotlin has that I really like that I hope Java gets someday, but probably won't, is named parameters and default parameters. So you can define, when you define a function, you can define default values for a parameter. And if you don't pass an argument for that when you call it, the compiler will inject it for you. So you could default all your parameters away in your declaration. And so when you call it, you can just call it with no parameters because the compiler will insert things for you when it builds. But there's from Java that gets weird because there's just the one method that takes all the parameters, and so you kind of lose some of that defaulted parameters. But there's an annotation you can use that Kotlin will actually generate multiple overloads. So it'll start from the very right-hand side and start peeling off the defaulted parameters, so that if there are four parameters with defaults, you get 5 methods, 4 or 5. So one that takes all the parameters, and then one that takes 3, and 2, then 1, and nothing. So you get that same feeling from Java.
Okay, actually, Mark is telling us some bytecode change indeed. They had to do some adjustment for Jacoco to support Kotlin 1.5. So there is something that changed. He already heads up.
Yeah, I have some tests that are failing because a method that I should have overwritten as part of my bytecode stuff wasn't for whatever reason. So I'm going to have to dig into that and just see what's going on.
Okay. We have another question from people moving from Java to Kotlin. Any advice on how to avoid bad practices from the Java world? Example, handling nulls.
How to avoid them? Well, generally speaking, okay, so I mentioned this project that I switched over in 2015, and it's It's a large-ish project. It's an IRC bot, so no money was riding on this particular conversion. But one of the things I noticed, like IntelliJ IDEA has an option. You can go in and say, convert this Java class to Kotlin, and it'll just blast it out for you automatically. And it gets you like 98% of the way there. But what I found was there's a whole lot of places in there where I was exposed to a null pointer exception because I wasn't checking for it. And so I had to go back and fix all those. But honestly, I would start. I would start with no. You put a question mark on a type that can be null, or on a field that question mark on the type for a field that can be null. I would start without those, honestly. So in that way, you're essentially telling the compiler nothing in my application can be null, and your code will break. It won't compile or whatever, but you'll start to see those places where a null may or may not creep in. But then you can evaluate those situations. You're like, no, actually, I never want a null there. So let's leave the question mark off. But then some place that is perfectly valid. So you can put a question mark in. You can start to kind of backfill in some of the nullability. And that's probably simpler than just marking everything as nullable, because then everywhere you use any of those fields, there's certain things you have to do to. There's a number of different ways you can check for null. And it's more work to go and add those everywhere than it is to just figure out where do we really want to allow nulls and then fix those places. Because generally we don't want nulls, right?
Yes. Another question that we have here, well, the practices we will already touch. There's why Kotlin and the leaves that you show will not be the new Groovy plus Grails. What's the big difference for you? I don't see, probably the person that asked this question can expand it because I think I missed something in the question. But I mean, okay. But
I'm trying to find that question. Okay, here it is.
Yes.
Why why they will not be then? Like,
yes.
what's to stop Kotlin from becoming Groovy?
Rails,
essentially.
Something. I mean,
Rails is basically Rails, but with Groovy. So I think there's a couple of differences. Groovy never really had much backing, corporately speaking. I have a lot of friends, including her husband, that are very into Groovy, so I have to be delicate in how I talk about it, because I have stuck my foot in my mouth a few times. It never had much corporate backing and never had a whole lot of developer buy-in. The people who did use it were very passionate about it and they loved it. But I think one of the things that turned me off about Groovy personally was it was a dynamically typed language, which I've never liked. I've been doing Java since 1996, since there was a Java, basically. And so being able to reason about types and validate things was like very important to me. And Groovy broke that contract. Even though the other language had some nice features, it was harder to reason about. And Kotlin is not that. It does a lot of type inference, which I think is amazing. But also the types are fixed and they're known. And so that's a big difference between Kotlin and Groovy. And also, like, Google is all in on Kotlin. It's the preferred recommended language for Android, for example. So I think it's going to be around for a while for that, if no other reason. But Kotlin has a lot more, I think, corporate backing than Groovy did.
That's true. IntelliJ, yes, it was. It is investing a lot. So there is another, just curious if there is anything with a more idiomatic Kotlin API.
Idiomatic for what? In what context?
That was the entire question. So maybe the other ones that I have for you is, what's the use case for Kotlin? What are the pros and cons? Like, probably the person was asking, like, where does Kotlin shine?
Where does it shine?
Amazingly.
Well, for me, one of the bigger things is I think the syntax is a lot sleeker. Java has come on quite a ways, and I think the value add for Kotlin is somewhat less now than it used to be. Certainly, like in the Java 6 days when Kotlin was really starting to rise to prominence, you could do all these amazing kind of modern lambdas and type inferences and all this sorts of thing on a JavaFX JVM, which was still, what, 40 years before Java actually adopted some of those features, right? And so then especially, and that's I think why it took off on Android, it really gave you kind of a modern language on an older JVM. That's changed a little bit. I still think the syntax is sleeker. I think when you start doing, like when you talk about Java streams versus Kotlin, I don't think you even call them streams, but you know, kind of all that sort of concepts. I think the syntax is nicer in Kotlin for that. There are certainly more functions available to you to kind of process your data stream. So there is that. I think we did not talk about it, and I kind of wanted to get a slide in on it, but it was difficult. Kotlin has coroutines, which is an implementation of what's called structured concurrency, which I only know because I've been reading about Kotlin coroutines. It doesn't mean a whole lot to me otherwise, but for the CS nerds out there. But it basically lets you write concurrent code like it's imperative. You know, like C# has its async await. There's like all these reactive APIs where you subscribe to this and on callback this and you know, you can get concurrent code with reactive messaging or asynchronous code with reactive whatever, but it's a massive buy-in to a really awkward, terrible API. But with Kotlin coroutines, for example, you just you have to launch it in a certain way because it needs a certain context. But then you just write your code, you know, foo this, bar that, blah, blah, blah. And the Kotlin compiler will actually build in all the stuff necessary to say, fire off this request off in a thread somewhere. You take care of that. I'm going to go work on this, and I will come back ready. So your code just looks like normal imperative code, but it's actually like highly scalable, like millions and millions of coroutines running on a single machine, as opposed to like Java threads. Once you get past 10,000, probably, certainly 100,000 threads, and you will turn your laptop into slag.
Yeah.
So coroutines are great. I'll be interested. Project Loom is coming up, and so that will be an interesting competitor to coroutines.
Yes.
But yeah, you know, it's not going to be in Java 17. It might be in 18. I don't know when it's going to land, but it'll be years before that becomes a common thing in the Java world, unless it's so compelling that everyone immediately says we should upgrade to Java 19 today, which would be amazing. I'd love it. But Java uptake typically has lagged quite a bit.
Actually, there are two questions very linked. Like after Java 17, is there anything like, let me quote that. You answer a little bit. After Java 17 LTS is out, what features are still lacking that you like in Kotlin? And the second that is very close to it, new features in Java, like for instance, Project Loom and virtual threads. Could this close the gap in functionality between languages and hit Kotlin? So they are thinking like, Java, it's picking up, so.
Yeah. Yeah, I think once Loom lands, it gets really interesting. Virtual threads will be interesting. I'm old enough to remember green threads back in the early JVM days. I don't know if anyone remembers those. But it feels like we're kind of veering back into that era again, although I think it's slightly different than the original green threads. Certainly that gap is closing, I think. The nice thing about still with Kotlin is they've been able to push the boundaries for what you can do on the JVM without requiring JVM updates. And some of the stuff that's coming in Java necessitates updates to the VM itself, which is fine, which is, you know, great. It's a slower process. So I think Kotlin will probably still outpace Java in that respect. But I think at some point, as much as I love Kotlin, and I absolutely love Java as well, I think the value proposition for rewrite your entire application in Kotlin becomes less at some point because the gap will be smaller for things that most people care about. Yes.
Actually, they were asking you about advices for developers either in Java or in C++. C#, sorry, moving to Kotlin. So do you have any advice?
My advice. Some of it's just kind of stock advice, but we'll see if something interesting comes out of it. One of the things that I've always learned or heard for years now, whenever, because the JVM is so great because there's literally hundreds of languages that run on the JVM. And everyone's always like, if you want to learn a new language, write your test in it first. You know, you're not necessarily betting the company on a test. You kind of are, but it's a little bit more indirect, right? If your test doesn't work, then suddenly you've just, I don't know, cost the company $1 billion. But you can start with writing small tests, for example, and just kind of get a feel for the language. And you know, it can be pretty bite-sized. I mentioned in the comments, setting up multi-language projects is not difficult. And if you go to the Kotlin website, there's instructions for both Maven and Gradle, depending on what your preference is. The Kotlin world seems to favor Gradle, but I think that's driven more by Android than anything else because Android builds on Gradle and not Maven. It's unfortunate, kind of an Asian guy. But I would start there and just start writing some tests. You could also, if you really wanted to, what I've actually done, because building Corcus is can be complicated. There's almost 900 modules inside Corcus. It's massive and it's small. So there's a few things that I've had to automate to help aid in my development. And I originally had bash scripts, which was fine because I'm a Linux nerd for decades now. But I actually went back and rewrote all those bash scripts using Kotlin and Corcus CLI, which, you know, sounds like a sales pitch, but it's what I work on, so I thought, I'm going to try this out. But I wrote all these dev scripts in Kotlin. So they're all running on the JVM. And they run so fast, it's like running a bash script. I never noticed the difference. But you can write fairly complex scripts that way in Kotlin and then run them. And then you really are kind of outside risking the actual product, you know, whatever your development scripts might happen to be. Rewrite them in Kotlin and see how it feels. You know, some things are going to be more awkward because interacting with the OS from the JVM, you know, execing things out is not so great. But you can play with the language at least in a way that doesn't threaten anything.
Yeah, true.
You're about to say something, Excel.
Yes, we need to wrap this, but we still have the Hangout, so we can meet there and we can still ask you questions over there. So let's move along.
Yes, I'll have to find that link, but it's around here somewhere.
Yeah, yes, it's around here. Actually, they posted in the chat. So there it is.
There's the Hangout. Okay, I'll click that link and see how that goes.
Okay, perfect. Then I will see you there.